Good day, 20-1s. It's another great day for some sequences and series. I know you're excited. All right, we're going to just go crazy with some more of the algebra stuff today. Building, though, if you notice today's lesson, page 11 of your booklets, we're looking at geometric sequences instead of arithmetic. Arithmetic, 5, 7, 9, 11, ... because each number has a d value of 2. It's increasing. That makes a geometric sequence. List of numbers, each number is increasing by a set value. Well, now that's no longer considered a geometric sequence. What we're looking at now with the geometric sequence, same kind of deal, but instead of having a d value, we're going to have an r value, which is essentially a factor. A common ratio is what it's referred to, but each number is going to increase by a common factor. So 2 to 4, there we're multiplying by 2. So to get the next number in the sequence, we would multiply by 2, and we would multiply by 2, and we would multiply by 2. And now we have a geometric sequence because a common ratio, the r value, is 2. So, different formulas, same kind of idea though, still basing it on a whole bunch of algebra. So, let's get into it some more. So, 5, 15, 45, 135, geometric sequence. Same kind of variables, which is great. T of n still represents the last term, often. The last term in a sequence if we don't know what it is. In this case, we know term 1 is 5, and that's what T1 still is, the first term. T2, term 2 is 15. Term 3 is 45. Term 4 is 135. So we can just keep going, and we'll finish with some unknown term whenever this sequence is supposed to end. That's what T of n represents. N, same as always, is the number of terms. In this case, we don't know what n is because of the ... telling us there's an infinite sequence, meaning it's just going forever. It doesn't tell us where it stops. And the d value, like we just talked about on the previous screen, d value, it doesn't exist. There is no d value because it's not a common difference. We now have the r value, the common ratio. How does 5 become 15? Multiply by 3. How does 15 become 45? Multiply by 3. 45 to 135, multiply by 3. So what are we looking at for an r value in this case? 3. And the r stands for the common ratio. That's where the r comes from. It's a ratio. What are we multiplying by? That's a geometric sequence. So, can you identify the r value in each sequence? Well, sometimes it's easy, right? 2 to 4, well, that's times 2. 4 to 6, okay, that's not times 2. So if it's not consistent, well, this is not a geometric sequence, which means there is no r value. R value, it's not applicable here, doesn't exist. What we do have to be careful with r value sometimes, it's just something you should be able to look at and figure out. 5 to negative 15, well, that's multiplying by a negative 3. Got to be careful. We're multiplying by negative. How does negative 15 become 45? Multiplied by negative 3, because negative 15 times negative 3, positive 45. So in this case, r value is negative 3. It is a geometric sequence. Not a problem. But still need to have the knowledge of fractions. Now, I realize calculator can work, but having fraction skills can be nice. It's essential as you move on. You choose to be in a 20-1 stream, higher level thinking, you should have this skill set. If you recall, to calculate the common difference, we could take any term. And to get the common difference, we would subtract the term that was previous to it. I could take term 87, and the common difference was based on subtracting the previous term. Well, it's the same idea to calculate an R value, is we're going to take a term, but we're going to divide by the term previous. So an R value can be calculated by taking a term and dividing by the previous one. Let's just look at B, which we already know the R value is -3. If I took -15 term 2 divided by term 1, -15 divided by 5, it's -3. There's our R value. Or I could take term 3, the 45, divided by term 2, the -15. 45 divided by -15, there's our R value, -3. So we can see that it works. So that's what's important to understand, that summarizing this, we can calculate R by taking a term and dividing it, sorry, not subtracting it, dividing it by the term previous. Term n divided by term n minus 1, the one right before it. So with C, with the fractions, well, a little bit of fraction work, I can take term 2 and divide it by term 1. But with fractions, we don't divide fractions, we multiply by the reciprocal. Cancel the 3's, leaves us with 2. So 1/3 to 2/3 is times 2. Well, let's double check if that's true for all of them. Now I have term 3, the 1, and I'm dividing by 2/3, which is the same as multiplying by the reciprocal. So in that case, 1 divided by 2/3, which is times 3/2. 1 times 3/2 is 3/2. Look at that. The R value doesn't exist. Not applicable, because I have an R value of 2 here, but I have an R value of 3/2 there. So this one is not a geometric sequence either, because the R value is not consistent. Let's try D. 3/8 divided by the previous one, 15/16, but I don't divide by that, I multiply by the reciprocal. Well, we can always cancel. 8 and 16 becomes a 1 and a 2. 3 and 15 becomes a 1 and a 5. So we get an R value of 2/5. Well, that should also be the same R value if I take my 3/20, my term 3, and divide it by the previous term, and dividing by 3/8 is the same as multiplying by 8/3. So do some canceling first. 20 and 8 will divide by 4. We get 2/5. So our R value is consistent in this case, and it's an R value of 2/5. Multiply by 2/5. Multiply by 2/5. So we can calculate an R value if it's not straightforward and easy to see. There you go. One you have to be careful of, something I just want to point out because students will sometimes make an error. If you have something like 24 and then 8, no, that's not a good example. I'm trying to think of an example that would work nice. Let's just do this. 16, 8, 4, 2, and so on. Well, I'll have students here that go 16 to 8, you divide by 2. 8 to 4, you divide by 2. 4 to 2, you divide by 2. So the R value is divide by 2. That's not correct. An R value is the factor, what you multiply by. Dividing is not an R value. How can you do this? Take the 8, term 2, divide it by the previous term 16. 8 over 16 is an R value of 1/2. Take the 4, divide it by the previous value, 4 over 8, divide it, doesn't divide even, so we just reduce it. R value is 1/2. So in this case, dividing doesn't cut it for an R value. R value, we're multiplying by 1/2. We're multiplying by 1/2. So be careful with that with your R values. Well, let's get into it now. Just like with arithmetic sequences, it's all about formulas. I'm not worried about how the formula gets created, not essential, but here's the formula we're dealing with. Sometimes we'll be asked to calculate the Tn value. Sometimes we might be asked to calculate an unknown variable if we know the T of n value. Same kind of idea. How we use it, what's our algebra skills like, that's up to you. We know that T of n is a particular term. We know T1 is the first term. We know now that R is your ratio, and we know n is the number of terms. So using that formula shouldn't be overly complicated. So here we go. Can we write the simplified T of n expression for the geometric sequences? So we just want to write the simplified expression. Like we did with arithmetic sequences, sometimes we just want a simpler form. What helps is to list what we know. What do we know for A? Well, with A, it's infinite, so we don't know what T of n is. That's just what we're trying to find. We know that our T1 is 2. And we know that our R value, 2 to 4, 4 to 8, R value is 2. So I now, because I don't know how many terms there are, I just want to simplify this as much as possible. T of n, using the appropriate formula, is equal to T1, which is 2, multiplied by R, which is 2, to the n minus 1. So in that case, there's what we're looking at for a simplified expression. Now in this case, we know that when we have two powers with the same bases, we keep the powers and we add the exponents. 1 plus n minus 1, 1 and negative 1 cancel, so this simplifies to just 2n. There's our simplified expression. Write what we can and then simplify it down. So for B, what do we know about B? Well, we don't know how many terms there are or what the last term is. We know term 1 is 5. What else do we know? We know the R value. We looked at this one earlier this lesson already. Multiplying each term by negative 3, so R is negative 3. So what's our T of n? Well, it's T1 times R, which is negative 3, to the n minus 1. However, we want all of negative 3 to be the base. Always put a negative base in brackets. So there's what we get for a simplified expression. Now, as we continue on, we now get to the fractional ones. And we all love the fractional ones. Well, a little bit more involved. Trying to find T of n. We know that T of 1 is 1/3. And do we know the R value? Well, we can calculate it. Take term 2, divide it by term 1, or multiply by the reciprocal. Cancel my 3's. R is 2. Let's double check that though. Take term 3, 4 over 3. Divide it by the previous term, so I'm dividing by 2/3, which is the same as multiplying by the reciprocal. 3 and 3 cancel, 2 becomes a 1, 4 becomes a 2, and we get an R value of 2. So we know that R is 2. So our simplified formula would be T sub n is term 1 times r to the n minus 1. And there's what we have for our simplified sequence. D. Pause it, give it a try, see what you come up with, and then let's do it together. See if you can do that one, though, on your own. Well, again, trying to simplify our T of n formula, we know that T of 1 is 15/16, and we can calculate R, but we don't know it. 3/8 divided by the previous term is the same as multiplying by the reciprocal. 8 and 16 will reduce, 3 and 15 will reduce, and we get a 2/5. So R is 2/5. We're going to multiply by 2/5. Well, with fractions, I want to double check that that's correct. So what's our other R value? Let's check. We know that 3/20 divided by the previous term or multiplied by the reciprocal of it. 3 and 3 cancel. 8 and 20 will reduce by 4. Leaves us with an R of 2/5. So it's consistent. So in this case, our T sub n value is equal to 15/16 times 2/5 to n minus 1. Now again, we want all of 2/5 to be to the exponent, so I should always put my fractional base in brackets, so I know the exponent n minus 1 is for everything. So, simplified expressions. This is just, do you know that it's a sequence, geometric? What are your values? Let's plug them in and simplify. Well, let's now look at some calculations. On page 13, we now start to look at actually finding certain values. So it's asking, for example, to find the indicated term. So it tells us they're geometric sequences, so we're trusting that they are, and we're going to use our formula. As always, I like to list what we don't know and what we do know. Term 6 is what we don't know, but we do know if we want term 6, there's 6 terms that we're dealing with. N is 6. We do know that T1 is 4, and we do know if we do a quick inspection, 4 to negative 12 is times negative 3. Negative 12 times negative 3 is positive 36. So we know that our R is negative 3. So now we can solve. The 6th term is based on term 1 times our R value. Make sure you put it in brackets so negative 3 is the base. And then it's n, which is 6, minus 1 for an exponent. Order of ops tells us, well, 6 minus 1 is 5, so I can turn that to a 5. So it's 4 times negative 3 to the 5. Order of ops tells me to do the exponent first. So negative 3 to the 5, and then multiply by 4. And our 6th term is negative 972 in this list. Again, as talked about in previous videos, if you want the 6th term, some people, multiply by negative 3, multiply by negative 3, multiply by negative 3 till I get to the 6th term. Not appropriate, because here we want you to do it using the formulas. But technically that would work. But look and watch for the word algebraically, so you have to do what's necessary. Term 3. For the 2/3, 4/5, ... It's only 3 terms. This one's not overly complicated, really. But let's follow the process, make sure we understand how our variables work. We're looking for the 3rd term. We know that n is 3 in this case because it's the 3rd term we're looking for. We know that term 1 is 2/3. The question is, what's r? Well, take a term 4/5, divide it by the previous term, which is to multiply by the reciprocal. A little bit of simplifying, and we end up with an R value of 6/5. So if I want term 3, that's telling me I want term 1, 2/3, times my R value, which is 6/5, to the exponent n minus 1, because n is 3. Term 3 will be 2/3 times 6/5 squared, because 3 minus 1 is 2. And if I do that calculation, 6/5 squared, 36/25 times 2/3 gives us the third value being 24/25. There we go. So, still about using a formula and being able to work with it. Question 3. Find the missing terms in each geometric sequence. Well, pros and cons, and again, it's algebraically or not. What's nice with this first question is we want the missing terms. Well, in this case, I'm not guessing and checking. I can calculate that our R value is 2. So that's information that's given to us. How would I get the previous term? Well, if I have to multiply by 2 to get 56, I'm going to divide by 2 to go this way, which would be 28. Divide by 2 to get the one previous, 14. Divide by 2. So in this case, because the R value's there, we're not guessing and checking a whole bunch of things to see if it works. We're using information. We calculate R to be 2, so then we can use it. However, with B, to go from 20 to 320, trying to figure out what the R value is, this would be guess and check. Yes, it would work, but as soon as you're just guessing and checking, then you're not following algebraic process. So now, what do we know in this case? Well, we know that term 1 is 20. We know that our T of n, or in this case, our fifth term, is 320. So now we can work because we know our T of n, or T5, we know term 1, and we know what n is because we know there's 5 terms. So we're going to calculate for R. So if Tn is 320, first term is 20 times the R value we don't know, but we do know our exponent is 5 minus 1. So from there, now we need to calculate. Well, we know that 5 minus 1, we know that that's a 4, R to the 4. I need to get the R by itself, which means I need to get rid of this 21st, which I can do by dividing because it's attached by multiplication. So I'm going to divide. That'll leave me with 16 equal to the R4. Well, I need to figure out what do I multiply by itself 4 times to get 16? Well, that's like saying I want the 4th root of 16. What times itself 4 times gets me 16? Well, that's 2. So in this case, our R value is 2. So now I can fill in the missing terms. Because 20 times 2 is 40. Times 2 is 80. Times 2 is 160. Times 2 gets me what we need, and that puts a smile on my face. So using the formula, but having to do some algebra to make it work. Example 4. Same kind of question, have some missing information, but like with arithmetic, this question tells me that my second term is 48, a third, a fourth, and I have a fifth term is 162. We want to find the R value and we want to find the first term. Well, I could just start guessing and checking to see if things work. But I don't just start throwing numbers in to see what's going to work. I have to do it algebraically. As much as this is the T1, what the question asks for, I can cheat to start with, and 162 is term 5, but I can work with T148, term 4, 162, because that's going to help me figure out what the R value is. So again, R is going to be the same all the way, whether I start with this term 1, or if I start with 48. So I'm going to cheat a little bit to figure out what R is. Term 1 is 48. Term 4 is 162, which tells us the number of terms is 4, because we have the fourth term, and we want to figure out what R is. So T of n, or in this case our fourth term is 162, and that's equal to term 1 times R to n minus 1, which we do know is 4 minus 1. So this is saying 162 equals 48 R cubed. Well, I need to get the R by itself. I'm going to divide by 48 to start. And 162 divided by 48 leaves me with 3.375. A decimal that's kind of ugly if I cube root that, because that's equal to R cubed. I want to know, what do I multiply by itself 3 times? So I need to cube root 3.375 to get my R value. Now, I got to pull up my calculator here. It'll take a second just to refresh your memory about your calculator and how to do roots that are kind of unique. I could have actually shown you this on a previous screen, but we'll make this work. All right, so if I want to cube root something on my calculator, I want to hit the math button on the left side towards the top. And then I can see that if I want to cube root, I can hit number 4, which is cube root. Or for the previous question where I wanted the fourth root, I can hit number 5, because that allows me to put in the index of 4. So on our graphing calculator, it's the math button. In this case, we want the cube root of 3.375, which equals 1.5, which is really 3/2. So in this case, R is 3/2. So we know with an R value of 3/2, how do I get the previous value? Well, if our R value tells us to multiply by 3/2, I need to divide by 3/2. 48 divided by 3/2 gives us 32 as a T1 value, which is what the question asked for. And R, so we know T1 is 32, R is 3/2. We've answered the question. So, same formula, just used in different ways depending upon what the question asks for. Now, we have word problems that are actually fairly practical word problems with a lot of these questions. So we have to, though, be careful because there's a little bit of thinking involved with these. So what we have to notice with this question is we are looking at the fact that a house is increasing by 4% each year. It's a $500,000 house. So the question says, what is the value of the house after 1 year? Now, why this becomes a little tricky is because our initial value is 500,000. That's our T1 value. So all of a sudden, after 1 year passes, add 1 year, now we're at term 2. So as much as it says, what's the value of the house after a year, we're actually looking for term 2. Well, here's the problem. Remember, working with a percent, we need to work with the decimal value of it. And I'll have some students go 500,000 times 0.04. So 500,000. Now I got to get rid of my point. There we go. 500,000 times the 4%. And you get $20,000. So some students say, oh, I'm going to multiply by 4% and get 20,000. So the $500,000 house becomes a $20,000 house. That doesn't make sense. We have to be careful with these questions when it talks about increasing. We still need the initial $500,000 price of the house. So we need 1 to represent the initial value, but we're then increasing by 4%. So we have to multiply by 1.04 because that's saying, hey, we need the initial price of the house and the extra 4%. So if I take my 500,000 and then I multiply by 1.04, the value of the house goes up to 520,000. That makes more sense. But understand, oops, not 52,000, goes up to 520,000. But this is now term 2, which is after 1 year. After 2 years, I need to do the same thing. But I'm adding 1 more year to after 2 years, but that's actually giving me the third term. So you have to be careful which term you're dealing with after so many years, because we're going to, again, multiply it by 1.04 to get the next increase. Now we're at 520,000 times 1.04. So what do we end up with? We end up with $540,800. So when you're increasing with percents, percent needs to be a decimal, but we need to include that 1 out front to work with it. So is this a geometric sequence? Yes, it is, because our R value of 1.04 happens year after year after year. So that's a little tricky with these. Now the second part to this, what's the value of the house after 8 years? Well, again, we have to be careful what we're using, because what do we know? We know that term 1 is 500,000. We know that our R value now is 1.04. But the question is, which term do we want? So term 1 is where we started. We're adding 1 year to term 2. We're adding a year to term 3. We're adding a year to term 4. So term 2 is after 1 year. Term 3 is after 2 years. Term 4 is after 3 years. So eventually, after 8 years, which term are we at? We're actually at term 9. And that's what we have to be careful of. So many people will say, oh, we want term 8, but we don't. We want term 9 because after 8 years, we're at term 9 because term 1 is our starting point. So it's a little tricky. You've got to watch it. Term 9, that's what we're trying to find, which means our n is equal to 9. So you really have to watch that. So now if I calculate, well, what's the value at term 9? Well, it's going to be T1, 500,000, times 1.04 to the 9 minus 1. And that works out do the exponent of 1.04 to the exponent 8 multiplied by 500,000. Term 9 is $684,284.53 after 8 years. Now, just to make things a little easier, if you can remember this, if you look at your formula sheet, on the formula sheet at the bottom of the number patterns, you have the formula A equals P bracket 1 plus or minus I to the N. This is a formula that we use for word problems for geometric sequences. Word problems. The A stands for the accrued amount, the total amount at the end. P is the principal, your starting amount. I is the interest, and in this case, N is after your time frame. So special formula, and this is where it becomes special, is this formula for word problems of geometric sequences. N is after the time frame in the question. We end up with the accrued amount is the principal, 500,000, times 1 plus the interest. So that brings that 1.04 into play. 1, and we're increasing by 4%, and it's after 8 years. So this is a shortcut to get to this formula here, which is just a way to know which exponent to use. It's a little tricky. After 8 years is really the 9th term. If you use this formula, it's just referring to 8 years. Gives us the same answer. So there is a bit of a shortcut on that formula page, but you really gotta think about which term you're dealing with. And then for D, after how many years will the house be worth at least $900,000? Well, how many years will it be? Let's use our abbreviated formula. A equals P 1 plus or minus I after so many years. Well, now we know we want at least $900,000. So our accrued amount is 900,000. We know we have our starting amount of 500,000. We know we have 1 plus or minus the interest, which is 1.04, but we don't know what the N is in this case. So how do we figure out that? Well, I can start by dividing by 500,000 on both sides. And when I divide by 500,000, I end up with 1.8 equals 1.04 to the N. Well, I need to, in order to find exponents, this now is a guess and check. We guess and check using 1.04 with different exponents so that we get at least 1.8. So what do we do on our calculator? Well, pull out our calculator, and we want to go 1.04 to some exponent. Let's try 10 and enter. 1.4. We want it to be what? We want it to be 1.8. Well, we're not big enough. So 1.04 exponent 12. We get 1.6. Still not big enough. The only way to calculate an exponent is guessing and checking. Let's go to 15. 1.800. There's what we need. We needed at least a value of 1.8. We got it. Let's just double check. If I do 1.04 exponent 14, yeah, 1.7, it wasn't enough. So our n value is now after 15 years. So we can go back, and we know that n is 15 years. So after 15 years, that house will be worth $900,000. So word problems. Unique because it's tricky figuring out your time frames. Last example, and then you'll get to work. Last example, it's the same kind of idea with a twist, because we know that clothing fades after washings. So the color in whatever it is, this company says 5% of the color fades after each wash. So what percent remains after one washing? Well, if we started with 100% color, you bought something, you wash it, we're down to 95%. So we know that what we start with, we're only going to end up with 95%. So that would be our R value. 100% to start with, but we're only going to have 95% after that. And then whatever color's there, we're going to only have 95% of it after that. So we can see that every time we wash, we're losing 5%, or we keep 95% of the color. 5% was lost, but 95% carries on. 5% was lost, 95% carries on. So if my term 1 was 100, what are the first 4 terms of the sequence? Well, there's term 1, term 2, term 3, and term 4. The first 4 terms, well, we know we're only keeping 95%. So we're going to have 95. After that, we know we're going to keep 95% of the color, so we would be down to 90.25. We know we're going to keep 95% of the color, so we're going to be down to 85.7. But what you have to be careful of, again, what are the first 4 terms? Well, we start with 100% of the color, then we're down to 95% of the original color, then down to 90%, then down to 85%. This is after how many washings, though? Term 4 is after 3 washings. Again, time frame's a little messed up, because term 1 doesn't count as a washing. There's 1 washing to term 2, 2 washings to term 3, 3 washings to term 4. So we have to be careful. So what's the R in this case? 0.95, because 95% remains and carries over from wash to wash. So with that, what percent of the color remains after 10 washings? Well, what do we know? We know that our initial amount, but again, word problem, geometric. Let's go to our special formula where I don't have to worry about which term it is. The accrued amount, the final amount, is based on our principal, which is 100% of the color, times interest was we lost 5%, so 1 minus the 5% leaves us with 0.95. Because this is a whole amount, but we lose 5% in this case, which leaves us with that R value of 0.95, and our N is after 10 washings. Figure it out. Decimal 95 exponent 10 times 100, it says 59.9%, so about 60% of the color remains. So there you go. If you want to use the initial formula, which term are we looking for? Well, term 1 is the start. 1 washing takes us to term 2. 2 washing takes us to term 3. 3 washing takes us to term 4. 4 washing takes us to 5. So 10 washings would take us to term 11. And if I use that formula, term 11 would be initial, which is 100, times our R value, 0.95, times N minus 1, which is still going to be our 10. 2 ways to look at the same question. And then finally, question E, how many washings to have approximately 25% of the color? Well, what do we know? A equals P, 1 plus or minus I to the N. Our accrued amount, we want about 25% of the color. Our principal amount, initial amount, was 100% of the color. We know we had 95% carry each time, and we're trying to figure out what N is. So, divide by 100, 0.25 equals 0.95 N. How do we figure out an exponent? This is done through guess and check. So we have to guess and check. Back to the calculator, 0.95 to end up with 0.25. So our 0.95 R value, we guess and check with exponents. We want to end up with 25% left. Let's say 20 washings, 0.35, not enough. How many more washings? Let's go to 30 washings, 0.953. Well, whoops, that didn't work. I was trying to figure out what the problem was. Exponent 30. What do we get? 0.21. We're down to 21%. We've washed it too many times. 0.95. Let's go to 25. There's 0.27. We still have about 25%. We still have too much color, so 0.95 to 20. Let's go to 27. There's our 0.25. 25% of the color remains after 27 washings. So there we go. Guess and check to figure out exponents. N equals 27 washings to have 25% of the color remain. There we go. So, there's your assignment. Textbook, page 39 to 43. One formula, but looking at all kinds of ways it gets utilized. Understanding geometric sequence is an R value. Same idea as arithmetics, but totally different. Practice and have fun.